In the last video, the workshop gave us this system. 3 unknowns, 3 equations. And we learned to write it as ax equals b. Now, we solve it. Here is the strategy. Some systems are almost effortless. Look at this shape, the last equation has a single unknown, so we solve it right away. We substitute its value into the equation above, and solve again. And then once more, up to the first. A triangular system, each equation hands its value to the one above. Gaussian elimination is exactly this idea. Simplify the system, step by step, until it becomes triangular, zeros below the diagonal. And to get there, we are allowed 3 moves. 3 moves that never change the solutions. Move 1, swap 2 equations. They are the same equations, so the same solutions. Only the order changed. Move 2, multiply an equation by any non-zero number. Both sides scale together, so the balance holds. And move 3, the workhorse, add a multiple of one equation to another. This is the move that will create the zeros. During these moves, the unknowns just sit there. So let's drop the dead weight and keep only the numbers, the coefficients, and the right-hand side, side by side. This is the augmented matrix. Each row is an equation, and the bar remembers where the equal sign was. Our 3 legal moves become row operations, with a compact notation, swap row I and row j scalar row. Or add a multiple of one row to another. So here is the plan, create zeros in these 3 positions, below the diagonal. Column by column, working from left to right. First move, swap row 1 and row 3, to get a 1 in the top corner. That entry is our first pivot. Now we clear the first column. Subtract row 1 from row 2, the first entry becomes a 0. And subtract twice row 1 from row 3. First column, done. Second column. A small trick, swap rows 2 and 3 first. The -1 is a friendlier pivot, and we avoid fractions. Now add twice row 2 to row 3. And there is the last 0. One final cosmetic move, flip the sign of row 2. And look at the shape. Zeros below a staircase of pivots. This is echelon form. The hard work is done. Time to harvest. Let's translate the staircase back into equations, writing every coefficient, including the zeros. And now watch the zeros do their job, term after term simply vanishes. What is left is triangular, just as planned. The last equation hands us x3 directly, x3 equals 1. The second equation is just as generous, x2 equals 2. The first one still mixes the 3 unknowns, but we already know 2 of them. Substitute x1 plus 2 plus 1 equals 6. So x1 equals 3. 3 tables, 2 chairs, 1 bookshelf, the workshop's production plan, solved. And notice how we got there. Not by clever guessing, but by an algorithm, a recipe a computer can follow, for 3 unknowns, or for 1,000. One warning, though. Our elimination went smoothly. But what if a pivot turns out to be 0? Or a whole row of zeros appears? Sometimes there is no solution at all. And sometimes, there are infinitely many. That is the next video.